In this section, we're talking about quadrilaterals. Quadrilaterals are four-sided polygons. In these pictures, we have two polygons that have four sides, so they're quadrilaterals. And you'll notice there's a red line that's connecting opposite vertices. For all quadrilaterals, if you connect opposite vertices, you'll split your quadrilateral into two triangles. And we know that the sum of the angles of any triangle equals 180 degrees. Well, if we have two triangles in any quadrilateral, we know that we have 180 degrees plus another 180 degrees. Therefore, the total for any quadrilateral is 360 degrees for the sum of the interior angles. Now, any polygon that has four sides is considered a quadrilateral. However, we do have two special types of quadrilaterals, trapezoids and parallelograms. In our first example here, you'll note that all our trapezoids in all three of these pictures have AC, side AC, and side BD parallel to each other. For our parallelograms, we have AC and BD parallel, so AC and BD, which I'm denoting with my arrows, and AB and CD, those sides are also parallel, which I'm using the same number of arrows to denote. So with parallelograms, we have two pair of parallel sides. With trapezoids, we have one pair of parallel sides, parallel. There are two main types of quadrilaterals, as I mentioned, and we're going to talk about some subtypes. So when we talk about trapezoids, they can come in all shapes and sizes, but there's a special one that you're probably thinking about when you think trapezoid. Is the way we see them a lot of times. It's referred to as an isosceles trapezoid. An isosceles trapezoid has congruent legs and congruent angles. So let's talk about what that means. The legs are the sides that are not parallel to each other. So in this case, side AC and side BD are parallel to each other. So AB and CD are the sides that are not parallel. Those are referred to as legs, and they're congruent when we have an isosceles trapezoid. The bottom angles, angle B and angle D, are congruent to each other, and the top angles, angles A and angle C, are congruent to each other. So those are all the properties for an isosceles trapezoid. With parallelograms, we have some main types. First, we have a rhombus, and then we have a rectangle. For a rhombus, it has all the characteristics of a parallelogram, and in addition to those characteristics, where opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, in addition to all of that, the sides are actually congruent. All four sides are congruent. A rectangle has all the properties of a parallelogram. It has opposite sides congruent, opposite sides parallel, opposite angles congruent, and in addition to that, all the angles are actually right angles, which is what makes it look like it's standing up straight. So all the angles are congruent. And there is a shape that is both a rhombus and a rectangle. You can think about it as a rhombus and a rectangle combined. It stands up straight, so it has four right angles, and all the sides are congruent. So it's a combination of both, and that's referred to as a square. So here's a flow chart to help you visualize the relationship between all the quadrilaterals that we're studying this year. So we see that trapezoids and parallelograms are the main types of quadrilaterals. Isosceles trapezoid is a special type of trapezoid. Rhombus and rectangle are special types of parallelograms, and the square is a rhombus and a rectangle put together. We have what's called a diagonal. A diagonal is a segment that crosses a polygon joining opposite vertices. So in this example, segment AD and segment BC are considered diagonals. So to review, parallelograms have two pair of parallel sides. They have opposite sides congruent and opposite angles congruent. There are three types of parallelograms: rhombus, rectangle, and square. So here's an example of an activity that you can try.